Hello and welcome to SigmaXL video tutorials. In this video, I'll be demonstrating the Friedman test and the Friedman exact test found in SigmaXL. The Friedman test is an extension of the Wilcoxon signed rank test and the non-parametric equivalent of a one-way repeated measures ANOVA. That is, one-way ANOVA on within subject ranks. The concept is the same as that of the paired t-test. We are interested in the within subject variability, not the subject-to-subject variability. It can also be considered as a non-parametric alternative to a DOE model with blocks or GLM with one fixed factor and one random factor. The Friedman test requires exactly one non-missing observation for each level of the treatment within each block. The null and alternative hypothesis are stated as shown. To begin, open Conover grass type experiment.xlsx. This data is from the Conover book, Practical Non-Parametric Statistics, 3rd edition. 12 homeowners are randomly selected to participate in an experiment with a plant nursery. Each homeowner was asked to select 4 fairly identical areas in their yard and to plant 4 different types of grass, one in each area. At the end of a specified length of time, each homeowner was asked to rank the grass types in order of preference. The data are given in tabular format, unstacked. Click SigmaXL, Statistical Tools, Non-Parametric Tests, Friedman Test. Ensure that the entire data table is selected. If not, check Use Entire Data Table. Click Next. Ensure that subgroups across rows is selected. Select grass 1 to grass 4. Click Numeric Data Variables Y. Click OK. The results show a p-value of 0.044 and tells us that we reject the null hypothesis. At least one pairwise set of medians are not equal, so there is a difference in the preference of grass types. That is, there is a difference in treatment effects. We will now redo this example to estimate the exact p-value using Monte Carlo. Typically, this would not be necessary unless the sample sizes were smaller, that is, n subjects less than or equal to 5. But this gives us continuity on the example. Click the Sheet 1 tab, or press F4. Click SigmaXL, Statistical Tools, Non-Parametric Tests, Exact, Friedman Test, Exact. Ensure that subgroups across rows is selected. Select grass 1 to grass 4. Click Numeric Data Variables Y. Select Monte Carlo Exact with the number of replications equal to 10,000 and confidence levels for p-value equal to 99%. The Monte Carlo 99% confidence interval for p-value is not the same as the confidence interval on the test statistic due to data sampling error. The confidence level for the hypothesis test statistic is still 95%, so all reported p-values less than 0.05 will be highlighted in red to indicate significance. The 99% Monte Carlo p-value confidence interval is due to the uncertainty in Monte Carlo sampling, and it becomes smaller as the number of replications increases, irrespective of the data sample size. The exact p-value will lie within the standard Monte Carlo confidence interval 99% of the time. Click OK. The Monte Carlo p-value is 0.0415 with a 99% confidence interval of 0.0364 to 0.0466. This will be slightly different every time it is run. The Monte Carlo seed value is derived from the system clock. So, we reject the null hypothesis. At least one pairwise set of medians are not equal. That is, there is a difference in the preference of grass types, or there's a difference in treatment effects. Note that the large sample p-value of 0.044 also lies within the Monte Carlo exact confidence interval. This concludes the SigmaXL video tutorial for Friedman and Friedman exact tests. For more videos, visit www.sigmaxl.com or join us on YouTube. Thank you for watching.